Welcome to Maths with Paro. In this video, I shall be discussing a question from January 2022 P2 paper. It is question 9 and the question is based on integration of curves. Here we go. The first part of the question is about there is a curve C and a line L, and both of them intersect at 0 as well as a point P. So here we have the curve y equals x minus x squared and the straight line y equals mx. Now we all know that when a curve and a line intersect, they meet at 2 points, and sometimes, in this case, they do meet at 2 points. And the way we find the points of intersection is by equating the equations of the curve and the line. So here is the equation of the curve. We equate it to the equation of the line, and we collect all the like terms onto one side. So we have x squared plus mx minus x. We can factorize out the x and write x squared plus x into m minus 1. Then we can factorize out an x from everything in the expression equation, and we have x into x plus m minus 1 equals 0. This leads us to x equals 0 or x plus m minus 1 equals 0, which in turn is going to lead us to x is equal to 1 minus m. Now we shall substitute that in the equation of the line, which is y is equal to mx. If we do that, we get y is equal to m into 1 minus m, since x is 1 minus m, and we end up with the expression m minus m squared. Now the question is to find the coordinates of p. So the x coordinate of p is 1 minus m, and the y coordinate of p is m minus m squared. Now this is part A of this question. Let's move on to part B. In part B, they are asking us to find R1. R1 is a region between the curve and the line. Now the way I'm going to approach it is, I first find the area of the curve from 0 up to the point of P. So I'm going to have a look at the area of the curve from 0 to point of P. So when I talk about integrating, when I write the expression, the integration from 0 to 1 of 1 minus m, 0 to 1 minus m of the curve, it's essentially taking this area that I have plus this area. This is what I mean by the area under the curve from 0 to 1 minus m. Now from that, if I subtract this triangle, I will end up with R1. That is why I have written R1 is equal to the entire area under the curve from 0 to 1 minus m minus the area of the triangle. Now what do I mean by the area under the curve? What I mean by the area under the curve is I integrate the expression for the curve, which is x minus x squared, minus what is the area of the triangle. Now the area of the triangle is half of base into height. The base is 1 minus m. The height is the y value of the line, which is y equals mx, so it's m into 1 minus m. So here I have the area of the triangle is 1 minus m into 1 minus m divided by 2. So what I end up having is the integration of x minus x squared, which is the integration of x is going to be x squared over 2. The integration of x squared is going to be x cubed over 3. And the limits are from 0 to 1 minus m. Then I subtract it from, if I have 1 minus m and 1 minus m squared, I can write it as 1 minus m the whole thing squared. So I simplify that. Now what I shall be doing is, I shall be looking at substituting the value for x of 1 minus m. So I end up with 1 minus m squared over 2 minus 1 minus m cubed over 3 minus the area of the triangle. Now let's have a look at what I get. I'm going to take out from this expression, I can take out a 1 minus x squared. So I can take a 1 minus x squared from here, I can take a 1 minus x squared from here, and I can take out a 1 minus m squared from here. So I take that out, I factorize it out. I'll be left with then a half minus a 1 minus m over 3 minus m over 2. Now I'm going to put them all under a common denominator of 6. And keeping in mind that I have already factorized out a 1 minus m squared. So what I end up with is 2 into 6, 3 is 6. So I have a 3 here. 3 into 2 is 6. So I have a 2 into minus 1 minus a 1 minus m, which is minus 2 plus 2m. Then I have 2 into 3 is 6, so I have m into 3, which is minus 3m. Now let me simplify what I have in purple there. So I will have the 1 minus m squared, which is out, and 3 minus 2 is 1, 2m minus 3m is minus m, so I have another 1 minus m here. 1 minus m squared into 1 minus m squared can be written as 1 minus m cubed over 6. So here I have proved what part B has wanted us to prove, which is that R1 is equal to 1 minus m cubed over 6. I know it's a little bit complicated, but I hope you were able to understand my explanation. Thank you, and let me now go on to the next part of this question. In this part, they say that the region R2 shown shaded is bounded by the curve C, the x-axis, and L. Now they say given that area of R1 equals area of R2, they want us to find the exact value of M. Now, how are we going to go about doing that? If we look at R2, we can say that R2 can be gotten by essentially the area of the curve from 0 to 1, that is this entire area, okay? R2 is the entire area minus R1, right? That would be how we can find out the area of R2, the entire area of the curve C1 from 0 to 1 minus the area of R1. But we also know that R2 is equal to R1. So first I'm going to write this equation. R2 is equal to the area under the curve from 0 to 1 minus R1. I think you all will agree with me on that. Now, since R2 is equal to R1, I'm going to replace R2 by R1. So I have another expression. R1 is equal to the integration of the curve from 0 to 1 minus R1. Now what I'm going to do is I'm going to put these two R1s onto the same side. So that will become 2R1 is equal to the integration of the curve from 0 to 1 of x minus x squared. Now when I integrate x, I get x squared over 2. If I integrate x squared, I get x cubed over 3. The limits are from 0 to 1. So here what happens, if I substitute 1 into x squared, I get 1 over 2 minus 1 over 3. And when I substitute 0, I get 0. So half minus 1 over 3 is 1 over 6. So here I have 1 over 6. Now, we have already gotten from the part B that R1 is equal to 1 minus m cubed over 6. So then what I'm going to do is, I'm going to simply equate R, which is 1 minus m cubed over 6, and I have 2R1, so I say it's 2 into 1 minus m cubed over 6, And that's equal to 1 over 6, because that's what I get for the integration of C, the curve. When I simplify it, it's clear that I have 2 into 1 minus m cubed is equal to 1. Therefore, 1 minus m cubed is equal to half. Therefore, 1 minus m is going to be 1 minus half to the power 1/3. And m is going to be 1 minus half to the power 1/3. Now, 1 minus half to the power 1/3 can be written as 1 minus the 1 over 2 to the power 1/3, which is 1 minus 1 over the cube root of 2. And that is my final answer. So when they ask for the exact value, the answer for the exact value is going to be 1 minus 1 over the cube root of 2. I hope you understood my explanation. Please send me a message if you want a more lengthier description. Thank you. That's all for now. Until my next video, goodbye.